Since the last video I did on the Clarion-Clipperton zone and polymetallic nodules seems to be attracting more interest than I was initially expecting, I thought I'd take the rather rare step of doing a follow-up video on the same broad topic. So far there haven't been a great many comments in the feedback, so I'm not entirely sure what people are actually focused on in the video. Instead, I'll go with what intrigued me about these nodules. These are fundamental basic questions of how did they get there, how do they form, and why are they in that part of the ocean and not found all over the ocean floor? First off, one thing I must rule out is any speculation that these nodules are the result of some object falling from space and crashing into the ocean, scattering debris all across the ocean floor. Now, even as spectacular as that would be, instead the answer is a little bit more mundane, but also intriguing when you dig into the process of what's actually been going on. Some people might tend to think of seawater as containing just water and salt. There's also a wide variety of other different atoms which are suspended in the average sample of seawater, including magnesium, sulfur, calcium, potassium, bromine, strontium, boron, aluminium, fluorine, phosphorus, copper, and more unusually, nickel, vanadium, molybdenum, lithium, copper, gold, and silver, and many more. I think I'll stop there. Precise amounts of each element vary quite widely, and some are only present in very, very tiny amounts. But due to the value of some of these elements, there are companies that are actively looking at ways to extract these elements floating around freely in the seawater. Hopefully the question that some of you are now pondering is, how did those elements get into the seawater in the first place? Well, surrounding all the water, whether it's in rivers or in oceans, are millions and millions of rocks. As the water flows over the rocks, it leaches some of the metals out of those rocks and into the water. These metals almost as easily fall out of the water as they fell in. It occurs with something that was known as redox oscillation. It's a chemical reaction involving the gain or loss of electrons. The process would start with a tiny grain or particle, and onto that particle slowly additional layers of metal would be added from the seawater. The additional layers of metals, most often iron or manganese, being deposited, creating a thicker and thicker deposit until the full nodule is then created. This gradual layering of deposits can also be shown when the nodules are actually cut in half. So inside the nodules are features similar to growth rings on trees, representing how each new layer of metal is added with different colours of rings representing different metals or different proportions of metals that were actually added. Different portions of metals brings me to another key point about the polymetallic nodules. Growth of the nodules represents the chemical mix of the ocean at the time, and this chemical mix will vary considerably both with time and also with local geography. Nodules found in different parts of the oceans contain significantly different chemical composition. So much like traditional mining, a company wants to extract valuable metals from the polymetallic nodules. Which metals they're searching for will in turn alter which part of the ocean they're going to search for those nodules in. The main consequences of this nodule harvesting will generally be twofold. Firstly, like most mining, there will be an environmental impact of the actual mining process itself. Secondly, the mining results in significant deposits being recovered. There will be an economic impact of those metals being put into the market, what then will have an effect on the price of metals, as it's likely to change the supply, if not also the demand for the metals. For example, most nodules consist of a lot of manganese, and currently most of the manganese produced is used in the production of steel. Potentially this will result in a reduction in the price of steel, possibly also create what's known as a Jevons paradox, with a reduction in the general price of steel coming from increasing supply of manganese, then ending up increasing the demand for this cheaper steel, and then in turn creating an increased demand for manganese.